Okay, so the next thing that we need to do after taking the input from the user is actually using this input to move the snake. Now, how do we move the snake? So this is gonna be a little bit tricky. So in this program, how we're gonna move the snake is actually going to be placed into a function that we're gonna call tick. So for each tick, the snake moves. So how a snake game works is actually a bit complicated. So I'm just going to show how that works. So for in snake, we have these blocks which make up a snake, or which make up the player who's controlling the snake. So let's say we have 3 blocks of a snake, and with each varying different x and y positions. So in this example, it looks like all y positions are the same, right? So if the player inputs, let's say, down, then the head of the snake, aka this one, needs to go down. So for example, this is the first tick, so this is tick number 1. In tick number 2, the head of the snake, the head of the snake will go here, for example. So it goes down. So these other 2 blocks need to follow it, and they need to follow it in a manner that's quote unquote delayed. So how does that work is the position of this of the head block here is actually already saved in some sort of struct that we're going to make. So we're going to have to make an array that holds all the positions of the blocks. So the the position of this head block, or the previous position of this head block, will be used by this block. So this block will go here. And then this block will use the position of the predecessor, which was this block here. And then it's going to take that position. So as you can see, it goes down like this. So, alright, so that's the first tick. In the next tick, let's say the player doesn't do anything, the snake continues down. This block goes down 1 block. So let's say right here. This block up here will also follow it through getting the position of where it was previously. So you see the pattern here, and this block will get the position this. So now it looks like this. So it's a bit distorted here, but I think you guys can understand the idea. And then if we go right, we can. It's actually the same process. So this one goes here. This block goes down here. This block goes down here. Hold on. Let me just clean it. Yeah. So this is what we're trying to do with the ticks. That's why we need to have a separate function that can control the logic for how the snake is going to look on the board, or how each block of the snake is going to be positioned on the board, so that it will look like it has a delay, like a real snake. So to do this, let us find a way to hold all the positions of the snake. So for that, I'm actually going to create a struct here. So struct snake positions, something like that. It doesn't really matter. And then it's just going to hold 2 int variables, which is x and y. And since this is going to hold each position of the snake, it's going to be an array. I mean, each position of the block of the snake, it's going to be an array. So I can just call the entire array player, since it's actually a player, and the maximum size of the snake. So I'm just going to put 100 here, or I can actually multiply this and this, so the snake can fill the entire screen or something like that, but it doesn't really matter. So there. So this is how I'm going to save each position of the snake. And then afterwards, I'm going to have to start moving the snake and filling up these positions. So how exactly am I going to do that? I am going to first create a function called tick, which will handle all that logic for me. So I'm going to create a void function called tick, and then make it a for loop that will start on some variable I will call num. And how this is going to work is that I'm going to go through um, each part of the snake. So num is going to be the size of the snake. So for example, this snake that we have in our MS Paint has a num size of 3. Since there are 3 blocks, if there was another block here, that would have a num size of 4, and so on and so forth. So that's what our value num is going to be. So since I haven't declared num yet, I'm going to declare here. So num equals, then we can set the default size of the snake, or what the snake is going to start with, like how many blocks it's going to start with. So I'm going to start with 4 for our num, so that we can have 4. Our snake will be of size 4, which we will see when we run this and when we complete this part of the program. So there. So I'm going to actually count down. So the reason why I'm counting down is because I'm coming from I need to extract the position of each predecessing block, and each block will actually be, so the predecessing block of the snake will actually be the lesser part of the array. So this is actually very tricky to explain, so I'm just going to code it honestly. So player I, so let's say something like this. So this is 4. The first time this will run will be 4. It's equal to player. So I need to get the predecessing block. Player, oops, player I minus 1, and then x. So I'll just equate it to that. So you can see that logic being coded out here. And here y and y. Okay. And then we also need to handle the direction and the movement of the snake. So because we equated this direction part, we can actually use the dir variable to control which way the snake is going. So that's just a simple if statement. So if direction is equal to 0, what's our 0 direction? It's down. This direction is equal to 0. Then player 0 dot y is plus equal to 1. And the reason why it's plus 1 instead of minus 1 is because in SFML, let's say this is our window, this part over here is 0, 0. And then it actually increases as it goes down. Y increases. If you go here, if you go right, x increases. So that's the reason for having it as plus equal 1, because we're going down. So I'm just going to copy paste this 3 times. And then we have 1, 2, 3. And what's our 1? Our 1 is going left, so that's minus. So minus equal 1. And then for 2, plus equal 1, because 2 is going right. And then finally for 3, minus equal 1, because that's going up. Wait, this isn't, yeah. Tama. Okay, so this is our tick function for now, and this will handle each tick of the game. So how are we going to use this function? First, we need to actually set up a timer for our program to use, because if we don't set up a timer, this will actually run on the speed of your computer, so how fast your computer will compute. So we need a way to limit that, so that the game will play slowly. So to do that, we should set up a timer here. So we can actually set it up below the render window. So I'm just going to comment called timer, and I'm going to use the clock feature of SFML. So I'm going to create a clock object from SFML, so SFML clock, and I'm also going to create a double timer. So I'm going to set this to 0, and the delay, which will be equal to 0.1. So this is the delay of your action, so you don't this doesn't spam as much, so it's gonna be a slow pace game. and then equals. Forgot. Okay. So now we're gonna have to use this timer. To use it, we go to the actual while loop of the program, and then we can create. Oh, sorry. We can create a float here called time, and we need to get the elapsed time of this clock. So this clock is actually in SFML. When we create a clock, we're actually starting a timer going up. So to get the data that this clock is producing, we need to take it through using this function within clock, which is get elapsed time. And then we also need to dictate as what time we're going to get it as, and we're going to get it as seconds. So like this. Okay. Then we're going to do a clock dot restart here. Restart the clock, and then timer plus equals time, which is this. So we're actually going to get each second of the clock. So once we get a second, we just add to the time. So we're going to count this game in seconds. So the next thing that we're going to do is to place the tick function. So we're going to place the tick function here. So let's create a new if statement. If timer is greater than delay, we can create a new tick. So we're going to reset the timer equal to 0, and then tick. Okay. So now we have I believe this will work, but before that we need to somehow draw our snake onto the window so that we can see this all in action. So for that, let's create, I'm going to comment here drawing. So this is the part where we draw the snake. So I'm going to create a for loop for each and every block of the snake. So int I equals 0, and we're going to traverse the blocks of the snake. So to do that, we go up to num. That's our condition. And then increment I, so I++. And then now we can actually get to use the snake class. So we can instantiate it with this constructor like so. So snake, so get this instantiated, and then let's create snake part. So this is just going to be a part of the snake. And then as you can see here, it accepts, we have to input the size and the color. So since each block is the size of each block is 16, we have to make it 16 by 16. So 16, 16, and then the color is SF color white. This is how you declare white in SFML. And then we need to use one of its I think it's called members. As we need to use one of its functions. I forgot what it's called. But the set position function of the class, and then we need to set its position to the current its current position taken from the structure array found here. So I'm just going to write that as player I.x times size, since we need to also take in we need to consider the size of each block, so that it's not a smooth snake, it's going to traverse each block, so it's as if it's jumping. And then we also need to get this button, the y coordinates. So I'm just going to do this, just copy paste it like that, and that should be done. And then lastly, we need to draw the snake part to window, just like that, and then assign window to the function, because as it says here, it requires the window address. So yeah, the clear should actually be on top, so I'm gonna move that here. and then display is here. So I'm just going to comment that as display, just gonna fix this. Then let's see if this works. I'm gonna press F5 to run it. If we get any errors, let's try to fix it, and there we go. We have a working snake game. So as you can see, each block is moving as per tick. So when I press down, it goes down, and if I go here, it actually disappears. Because we haven't coded the wrapping yet, but so you can see this is the movement of the snake, and yep, that's about it. You can also full screen it if you want to see it super close, and yeah, that's it. Alright, now let's work on wrapping the snake really quickly. So to do this, let's go back to our tick function, and then we can add a comment here that says wrap around walls. And then we just need to put an if statement here. So if the head of the player, which is 0, that x of the position is greater than n, which is the maximum part of the wall, which is virtual name n, then player 0 that x will wrap to 0, which is the left side of the wall. So if the player goes right, we'll wrap to the left side. Now if the player goes left, which is 0, since to be less than 0, then x will be equal to n. And then we do the same for y. So y instead of n, we actually do m. So we add, we put m here, and then for here is 0 and m. So let's test this out if my logic is correct. Oh, it actually disappears. Okay, wait. Let's test. Let's fix this. This should be. Oh. Oh, this should be y. This should be y as well. Okay. So press F5. Run thing. So if I do this, as you can see, it wraps around. So easy. Just 4 lines of code.